A linear transformation is just changing the way a line exists based on what you do to it. And there's basically four options of changes that you can do to a line. Those options are a times f of x, f of bx, f of x plus or minus c, and f of x plus or minus d. So those are the four options that we're looking at. So basically this first one says I multiply the whole function by a, whatever that is. The second one here says I multiply just the x inside the function by b. This third one here says I add or subtract c from x inside the function. And this last one says I add or subtract d at the end of the function. And I'll explain all those shortly. Okay, let's look at this function here. F of x equals 2x plus 4. So the slope is 2, positive 2, and the y-intercept is positive 4 on the y-axis. Okay, so this first one, a multiplier. So what if I said, what does 3 times f of x look like? Okay, well it's 3 times the whole function, so it's basically 3 times 2x plus 4. Then you just distribute. 3 times 2x is 6x, and then 3 times 4 is 12. So you end up with your new, so 3 times f of x is equal to 6x plus 12. So that makes the new y-intercept 12 and the new slope of 6. Okay, which moves a line off of this graph here. It moves the y-intercept way up there to 12, and it has a steeper slope of 6. But that's what that transformation does. So it changes the slope and it changes the y-intercept. Okay, let's look at the next option where you're multiplying, but this time it's inside the parentheses. So f of 3x is basically saying 2, and now I'll put a 3x here, plus 4. Okay, because all I did was replace the x with a 3x. See, I replaced that x with a 3x, and that's why it's there. So when I multiply that out, I can say f of 3x is equal to 2 times 3x is 6x plus 4. Notice the y-intercept didn't change this time, okay? But the slope did. The slope changed. The slope increased immensely. So 1, 2, 3, 4, 5, 6. So now the slope looks like this rather than what it looked like before, where it kind of looked like that. Okay? So when you're multiplying inside the parentheses, the y-intercept didn't change, but the slope changes. Now we're adding or subtracting inside the parentheses, and it doesn't matter whether you're adding or subtracting because you do this basically the same thing for either one. So you just substitute x plus 3 in this case for x. Okay, so now you have 2x plus 3. You see the x there? Now it's x plus 3 plus 4. So you have to distribute here. 2 times x is 2x. 2 times 3 is 6 plus 4. You can combine these two terms and you end up with 2x plus 10. So now you can see when you do that, look at the slopes. The slopes don't change, but the y-intercept did change. See, it went from 4 to 10. But the slope stayed the same, so the whole line just kind of moves up. If you subtract it instead of add it, you basically do the same thing. You have to distribute and combine like terms, and it would have moved everything down instead of up. But that's, and you notice when you're moving up here, what you're also doing, because the whole line now moves up, so the whole line kind of goes up there because the new y-intercept is plus 10. So you're actually moving to the left. When you add, you notice you move to the left, and when you subtract, the line will move to the right. Even though it does change the y-intercept, what it's really doing is moving to the left or to the right. So I moved 3 places to the left by going plus 3 right here. So 1, 2, 3. So that line should have gone through there, and it goes up to y equals 10. Okay. And in the last case here, where I'm adding or subtracting outside of the function, in this case I go from f of x equals 2x plus 4 to f of x plus 3, and all I do is just write the original function, 2x plus 4, and then plus 3 at the end. So I can combine those two terms and it ends up being 2x plus 7. So the slope stays the same, 2, but I move it up 3. So in essence, when I add or subtract outside of the function, I move it up or down depending on adding or subtracting. When I'm adding or subtracting inside of the function, I'm moving it left or right. But it's counterintuitive. If I'm adding on the inside of the function, I move it left. You would think it goes going negative, so you're subtracting, but it doesn't work that way. And if I'm subtracting, I move the line to the right that many places. And those are the 4 scenarios for transformations. We'll do some examples in class.